Okay, for problem 3.8 here, he wants us to use the anti-symmetry of omega in mu and nu, or in other words, equation 3.415 to show this relation. And then once we've done that, we can use this formula together with 3.4.23, which I've put on the right here, to solve for omega, lambda, mu, nu in terms of commutators or anti-symmetrized derivatives of the orthonormal basis vectors. Okay, so let's do that. Okay, so the anti-symmetry property that we're asked to make use of is this one. So if we swap, let me write that mu a little better. If we swap the last two indices, we just get this minus sign out front. So the way I like to approach problems like this, where we have these one forms that are anti-symmetrized over particular indices or whatever, and we're trying to show some relation, I like to just write these explicitly first and then see if we can show that it's equal to the left-hand side. So let's do that. I'm going to scroll down a little bit. We can say, consider and we'll do, oops, lambda mu nu. So this is this first term and what we're trying to show. So let's just expand it. So we're going to get 1/6 out front. I think it's 1/3 factorial, because you get 3 times 2 times 1. And then we can write this in all the different ways that it can be written. So we can go ahead with that. Omega lambda mu nu minus omega lambda nu mu plus omega nu lambda mu minus omega nu mu lambda plus omega mu nu lambda minus omega mu lambda nu. So that's all the permutations of the indices now. Oops, and this should be a circular bracket, not square. Okay, so we can simplify this a little bit by utilizing the anti-symmetry property. So we notice that we have lambda mu nu here, and then we have lambda nu mu. So it's just those two indices flipped, and it's a minus sign. So if we were to flip them again and bring the other minus sign out, we essentially end up with 2 times omega lambda mu nu. And for each term, we're going to get a similar thing here. These two that start with nu, we can use the anti-symmetry property to group them together as 2 omega nu lambda mu. And for the last pair as well, plus 2 omega mu nu lambda. So we can pull those 2's out, and this is going to end up being 1/3 omega lambda mu nu plus omega nu lambda mu plus omega mu nu lambda. Okay, so that's fine. I'll just remind us what we're actually calculating here. So this is omega anti-symmetrized over lambda mu and nu. And we can come back to this. So we can also now consider the other term that shows up on the right-hand side of the equation. So I'll scroll up and remind you guys that we have this omega anti-symmetrized over mu and nu, and then a lambda at the end. So let's consider that and also expand it out similarly to how we did for the last one. So that's going to be omega mu nu lambda. And so in this case, we just get a 1/2 out front. Omega mu nu lambda minus the first two indices swapped, so nu mu lambda. So now we have these two expressions. And so what we want to do is take 3 times this first one and subtract 2 times the second one. So effectively the 3 and the 2 are just going to get rid of the fractions out front. So let's say 3 omega lambda mu nu minus 2 omega mu nu lambda is going to be, okay, so the 1/3 goes away, and we get omega lambda mu nu plus omega nu lambda mu plus omega mu nu lambda minus, and then again, the 1/2 is going to go away because of the 2, and we get omega mu nu lambda minus omega nu lambda. Okay, and so we'll notice here we have, let's see, nu lambda mu, and these minus are going to cancel, nu mu lambda, so the anti-symmetry property will make this term cancel with this term. These terms are already the same, so we see directly that they cancel, and we get omega lambda mu nu as a result. And let's make sure that's what we were trying to show. Lambda mu nu, yeah, it is. So that's the first part. Okay, so that's good. Now we can move on to the second part, where he wants us to use this expression along with 3.4.23 up here. So I'm going to bring this down to our working spot. Okay, so we should be able to combine these in some way and show, to solve for omega lambda mu nu in terms of commutators or anti-symmetrized derivatives. Okay. So what we're actually going to do, first let's just write out 3.4.23 again in the way that's going to be relevant for us. So we have omega mu sigma nu minus omega nu sigma mu equals, and we're just going to take, we want this in terms of commutators, I guess, so we'll take what's on the left-hand side here. We're going to say it's E sigma A, E mu here, E nu A. So we're going to call this equation 1, and what I'm going to do now is just like a little trick that often helps for these types of index problems. We're going to rewrite this equation in a couple different ways just by switching indices. So I'm going to rewrite it now by taking mu and letting it go to sigma, sigma going to nu, and nu going to mu. And this will give us equation 2. So this is going to look like omega. So again, the mu goes to sigma, the sigma goes to nu, nu goes to mu, sigma nu mu, and then we're going to get minus omega, now it's going to be mu nu sigma equals E nu A E sigma E mu A up here. So we're going to call this equation 2, and again, all I'm doing is rewriting the indices with this rule that we've defined up here. So we're going to use the same rule again now. Whatever we have called mu in equation 2, we're going to let it go to sigma. We're going to let sigma go to nu again. We're going to let nu go to mu. And this is going to give us a third equation. Omega nu mu sigma minus omega sigma mu nu equals E mu A E nu E sigma A. And this is going to be equation 3. So after a bit of trial and error, what I found was taking equation 1, adding equation 2, and subtracting equation 3 is going to give us what we want effectively here. So let's start off by, I'm going to take 1 and subtract 3 to start. that's going to look like this. We get omega mu sigma nu minus omega nu sigma mu. This is going to be minus omega nu mu sigma minus omega sigma mu nu. So due to the anti-symmetry property, this is going to cancel with this. And so, yeah, we're just doing the left-hand side right now. And this is going to give us omega mu sigma nu plus omega sigma mu nu. So now if we add 2 to this, I'm just going to show that it gives us what we're looking for. So the left-hand side is then going to be these 2 omega mu sigma nu plus omega sigma mu nu plus the left-hand side of equation 2. So we're going to get plus omega sigma nu mu minus omega mu nu sigma. Now again, thanks to anti-symmetry, these 2 in the middle are going to cancel. And then we can rewrite this last one as mu sigma nu by flipping those indices and getting rid of the minus sign. And so we get on this side 2 omega mu sigma nu. So what we've shown essentially is that by taking this combination of the equations, we get an expression that's going to solve for omega directly here. So let's do the right-hand side now and find out what this equals essentially, and then we'll be done. So we can do this more directly. We're going to do 1 plus 2 minus 3 here. So let's go ahead. Equals, okay. So 1 e sigma a e mu e nu a. So that's equation 1. We're going to add equation 2 now. E nu a e sigma e mu a, and then we're going to subtract off equation 3. So we get e mu a e nu e sigma a. So in other words, if we want to rewrite this quickly, omega mu sigma nu is 1/2 e sigma a e mu e nu a plus e nu a e sigma e mu a minus e mu a e nu e sigma a. And that is the result that we were looking for. Now I think in the problem they had the indices labeled differently, in which case, let's just see. Yeah, lambda mu nu, and we have mu sigma nu. So we would just want to rename, if we wanted to match their notation, we would let mu go to lambda, we would let sigma go to mu, and we would keep nu as it is, and then it would match the notation of the problem statement. I'm not going to do that though, it's trivial. Yeah, and then that's it for this problem, that's the solution.